Okay, welcome. We're going to do the practice test to prepare for our test tomorrow. Okay, so it says in the parallelogram below, find x, y, and z. Okay, so since it's a parallelogram, we know something about the angles, and these are all angles, right? So we're going to use the angle that we know, which is this angle here, 114. We're going to use that to find the missing angles. Okay, so the first thing we know about parallelograms is that opposite angles, meaning across from each other, so this angle and that angle, opposite angles are congruent. So I would say negative x minus 7 has to equal 114. I'm going to move over the 7, and I get 121, right? I'm adding 7 to get that, by the way. And then to get rid of the negative, right? This is like saying negative 1 over x. So I just divide by negative 1, and I would get x equals negative 121. Okay. So opposite angles are congruent. Consecutive angles, meaning angles that are right next to each other, are supplementary. So to get y, I know that these two angles have to be supplementary. So in other words, 114 plus 5y minus 9 equals 180. 114 minus 9. Well, 114 minus 10 would be 104, so 9 would be 105. And then we have to subtract 105 to get 5y equals 75. And then dividing, if 5y equals 75, then y would equal 15. Okay, so y equals 15. And then z. Well, z, once again with that angle, it's consecutive. It's not across, so it's not an opposite angle. It's right next to. So once again, they're supplementary when they're right next to. So you would say 114 plus negative z. Give myself a little bit more space. Say 114 plus negative z minus 5 equals 180. 114 minus 5, well, that's 109. I'm going to subtract 109, and I get 71. Right, and then I would divide by negative 1, and I would get negative 71. So to get rid of the negative, remember, you just change the sign. So that's negative 71. And we're done. Okay, so for this next one, in polygon LMNO, we know that LM is equal to NO, which is and MN is equal to OL. And we know all the angles are equal. I'm going to draw a diagram and state what type of quadrilateral it is. So I'm just going to draw a diagram real quick. I don't really yet know what type of shape it is. So I'm just going to draw a regular old parallelogram. All right. And then we'll see. So this is LMNO. Okay, it's telling us that LM, that's this, is congruent to NO. So the opposite sides are congruent. MMN is congruent to OL. Okay. And then we know that angle L is congruent to, so this angle is congruent to this angle, which is congruent to this angle, which is congruent to this angle. Okay, and by the way, if we know that they're congruent, well, the only way that you could have 4 congruent angles add up to 360 is if they're each 90. So they actually have to be 90. If they're all congruent, the parallelogram that has 4 congruent angles and 2 pairs of opposite sides is a rectangle. And that's because all of the angles are congruent. That's what makes a rectangle a rectangle. Okay, so obviously my drawing is not accurate because I drew a parallelogram, so it would have to look right right? If you needed to redraw it, you would just draw it like this. Not important though. Remember, drawing we just use for visualization purposes. Okay, in the following polygon QRST, the opposite sides are parallel. Okay, so we know just from the picture, I'm just going to draw a regular old parallelogram. I don't know what it is yet, so obviously this isn't going to be an accurate picture. But once again, just for visualization purposes. So this is QRST. And then they're saying Q is congruent to S, so the opposite angles are congruent, and R is congruent to T. Opposite angles are congruent, so that's and the opposite sides are parallel, so that's definitely a parallelogram. And they're saying the diagonals are perpendicular, so the diagonals are perpendicular. That makes 4 right angles. Right? Perpendicular means in the middle, forms 4 right angles. Okay, since that's true, that makes it a rhombus. Because a rhombus is the one that has the diagonals that are perpendicular. Okay, so what type of quadrilateral is pictured below, and how do you know? Well, when I look at this, I know that there's no pairs of parallel sides, right? So if I did this side, I think I said... right, none of the sides are parallel. And then we also have the consecutive interior, instead of it being like a parallelogram, where I have opposite sides are congruent. Opposite sides aren't congruent, right? So the reason why I know that this is a kite is because we have 2 pairs of adjacent congruent sides. Okay, so what I mean by that is a parallelogram, the opposite sides are congruent. So if this is a parallelogram, this side would be congruent to this, and this would be congruent to this. Okay, so notice they're not right next to each other. But for this problem, the opposite sides aren't congruent. It's the adjacent side. In other words, the sides that are right next to each other, right? That's why I know it's a kite. Okay? So, since it's a kite, I know that this is the longer diagonal because it's between, right, the tick marks. It separates the tick marks. Okay? So, I know that quadrilaterals add up to 360. And we don't know what these angles are, but one of the properties of a kite says that the opposite angles, or the angles opposite the longer diagonal, are congruent. So since that's a fact, we know that this is x, and that is x. Okay? And then when you add them all up, we know that they have to be 360, because in a quadrilateral, the sum of the interior angles adds up to 360. Okay, so I would say 2x, 70 plus 66, what's that? 133. Right, that's 133. And then we're going to subtract 133, 360. And I'm going to get, right, when I subtract, you get 227. Right? Let me double check. 70 plus 66 is indeed it's 136. That's why. Can't add. Why'd I put 133? This is 136. All I did is I added these two, and I just added wrong on the video. Bummer. Adding is hard, okay? So when you subtract 360 from 136, what you get is you get 224. And then dividing by 2, you end up with 224 divided by 2 is 112. Okay, and that is what F is. Okay, so in this kite, they're telling us it's a kite. So in this kite, BAE, that's this full angle here, is 28. And BCE, that's this angle here. I'll put it here, then I'll have space. That's 57. Okay, and what they want us to do is they want us to find BAD. Okay, so I misspoke here. They're saying BAE is 28. Okay, so BAE, that's just this. Okay, the first thing they want us to find is this right here. Okay, well, I know that this is the longer diagonal of the kite because it's between the tick marks. And we know that the longer diagonal bisects every angle that it intersects. Okay, in other words, it creates two congruent angles. So if this is 28, since the longer diagonal bisects, this would also be 28. Okay, so those are both 28, which means BAD, which would be the full angle. So BAD would be both of those angles added up, because BAD is the full angle, 28 plus 28. And that would be 56. Okay, so if you're looking for CBE, well, since it's a kite, right, and CBE, by the way, CBE, we're looking for this angle right here, right, CBE. Okay, so let's zoom in on that. Since it's a kite, I know that this is perpendicular, so let me just draw that triangle just real quick so we can see it a little better. We're going to zoom in on just this triangle. So this triangle is B, E, and C. That's the right angle, right? That's 57. We're looking for that angle right there. Well, since we're looking for that angle, we know that the triangles add up to 180, or the interior angles add up to 180. So if this was X and I wanted to find it, that is what it is. That's CBE. I would know that the measure of CBE equals 180 minus X minus 57. Sorry, why did I put X, right? X is what we're trying to find, right? 180 minus 90, that's the right angle, minus 57. 90 minus 57, that's 43. There's your angle. Okay, so what type of quadrilateral is below, and how do we know? Well, in this case, only one side is parallel. So if you look at this, those are the parallel sides. Right? If I extended them forever, they wouldn't touch. So those are parallel. I forgot to include it in the picture. Right? Which makes this a isosceles triangle because we have two pairs of congruent sides. I said triangle, but I meant trapezoid. So this is isosceles trapezoid. And the reason why is we have one pair of parallel sides. Okay, so since it's a trapezoid, well, these special angles, the top and the bottom, are called base angles, right? And there's a property that says, hey, base angles are congruent, so these would be congruent. And then you solve. $100 minus 34 is 66. And then you're going to divide by 6. And you get x equals 11. And you're done. Okay, so in this case of this trapezoid, we just need to find the question mark. Okay, so remember that's we have a theorem that says the median is like the average of the top and the bottom. Okay, so that's the median. So, in other words, we need to find... Sorry. I didn't mean to put the numbers in already. It's base 1. Right, there's 2 bases. So, the bases of the trapezoid... This would be a base. And that would be a base. And this is the median. Okay? So, filling in that information, we know the median's 19. The 19 has to equal 1/2 13 plus the question mark, the other base. Okay, now to solve, well, we got to get rid of the fraction, so let's multiply by 2. Okay, so the 2's are going to cancel here. So 2 times 19, well, 2 times 20 would be 40. So 19 would be 2 less than that, so that's 38. And the fraction goes away. So if I wanted to find question mark, I would just subtract. And I would get question mark is equal to 38 minus 13, which is 25. Okay, so in this polygon, we know that LJ is congruent to KM. So we have this is congruent to this. Okay, so we know that those are congruent. And what they want us to do is tell us what type of polygon they are. Well, those are diagonals, so we know that it's a rectangle because the diagonals are congruent. Okay, so if KLN, and that's just right here, KLN, that's 12x minus 2. And NLM, that's 3x plus 7. Well, we know we want to solve for x. We know that each corner has to be 90 degrees. So when I add these up, I have to get 90, right? Because that's 90, that's 90, that's 90. And these angles together make it one of the corners, right? Okay, so we just add like terms. That's 15x plus 15 equals 90. Then I subtract. 15x equals 75. And then I divide. 75 divided by 15. That's 5. And we're done. Okay, we're going to use the shortcuts to determine if the triangles are similar. So let's do that. So for this one, I notice I have an angle. I have 3 sides here, but I only have 2 sides over there. So I know that I can't use side, side, side because I don't have all the sides. I can't use angle, angle because I only have one of the angles. So it tells me I have to use side, angle, side. So let's check. In order to be side, angle, side, the sides have to be proportional. Okay, so let's draw, it kind of helps to do the letters. So this is L, M, K, right? And this is N, O, P. Okay, so KM, well, that would correspond to OP. Right? So you would say we're going smaller to bigger. So I'm just going to make that real quick. Smaller to bigger. Right? And that would be 16 corresponds to 60. Okay, well, I know that 16 is 4 times 4. And 60 is 4 times 15. Right? Because 15 times 2 would be 30. Okay, so the 4's cancel, and I get 4 over 15. If you want that as a decimal, that would be 0.27. Okay, so if it's similar by side angle side, then the other congruent side, or the other corresponding sides, KL, which corresponds to NP, those also have to be the same proportion. Okay, so let's see. 20 over 48. Well, I know that what goes into 48? Well, just a 2. 4 goes into both, right? 48 is 4 times 12, right? So if I take 4 out, then this would be 4 times 5, 4 times 12, so the 4's cancel, and I get 5 over 12. If I put that in my calculator, I would get 5 divided by 12 is approximately 0.41. They're not the same proportion, so that means they're not similar. So we used up all of our tricks, and none of them worked. Okay, so for this one, we're going to once again have to find what's similar. Okay, so let's write the letters first. This is P, Q, R. This is S, T, U. Okay, so let's see what goes with what. So P, Q, R. So we only have sides, which tells me that the only thing we're going to use is side, side, side. Okay, so P, Q. That corresponds to ST. Okay, so we're going to say, what's the ratio of 8 to 24? Well, 24 is 8 times 3. So the 8's cancel, and I get left with 1 over 3. Okay, so now we need to find the ratio. What corresponds to PR? Well, PR is the first and the third letter. So SU will correspond to the PR because it's the first and the third letter. Okay, so we're going to say 6 over 18. Once again, 18 is 6 times 3. So the 6's cancel, and I get left with 1/3. So far, so good. If I have one more side that's congruent, then that means that they're similar. So this side, RQ, the second and the third letter, corresponds to this side right here. So I would say 6 corresponds to 20. Okay, so 6 corresponds to 20. Well, 20 is 2 times 10, and 6 is 2 times 3. So this would be 2 times 3 over 2 times 10. That would be a 3 over 10 ratio. And that is not the same as those two. So we tried side, 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 but these are not similar because none of the things worked. Are these triangles similar? Well, let's find out. So in this case, we have 2 angles. We would like the third angle. Okay, so this angle here we would need, we'll call this X. Let's find that. Well, we have 2 of the interior angles. We can find the third one. It's just 180 minus those other 2. See what we get when we do that. So we get 180 minus 60 minus 53. That's 67. So this angle is 67. They're all angles. So do we have 2 angles that are congruent? Well, I know that this angle is congruent to that angle. So I would say that GHI is congruent to FED. Right? And I also know that this angle is congruent to that angle. So that would be EFD is congruent to HIG. That's two angles, so I know that they are similar. So I would say triangle EFD is similar to triangle. I did E first, so I have to make sure I do H first because that's what corresponds to E. So it'd be HIG. Okay, and so that means they're similar by angle. Okay, so Stacy notices that another tree casts a shadow and suggests using the shadow method to calculate the tree's height. She lines herself up with the tree's shadow, so the tip of her shadow and the tip of the tree shadow meet. She then measures the distance from herself to the tip of the shadow, and then measures the distance from herself to the tree. Okay, so calculate the height of the tree. Okay, so in this particular example, she knows the height of herself is 550, right? And both this angle is in both the small triangle and it's in the big triangle, right? So that would be congruent to itself. So you would say both triangles are similar by angle. Okay, now since that, we can start setting up proportions. Okay, so if this is the height of the tree, we'll call that x. Well, we would say her height corresponds to the height of the tree. And the base of the smaller triangle corresponds to the base of the big triangle. All right, this is the smaller triangle. That corresponds to the big. All right, this is her height. That corresponds to this height. Okay, so then we're going to cross multiply. And what do we get? So we're going to get 15 times 5.5 is equal to 6x. 15 times 5.5. That's 82.5. If I divide that by 6, then I get 82.5 divided by 6 is 13.75. All right, and we're done.